Now we need to perform some hypothesis testing on the two data sets that we have here. So again, we're looking at proboscis length between two butterfly species as well as body mass differences between the same two species. We have our raw data, we have our statistics here, we have our standard deviation, measure of variance, and variability, and we have our two graphs. We can see we've put on our standard deviation error bars. For the mean proboscis length, we can see there's a significant amount of overlap between the two error bars. Already, this is suggesting that there is no significant difference between the two data sets. Over here, on the other hand, we're on the cusp. We have overlap, obviously, but there might still be a statistically significant difference between these two species in terms of body mass. You can see here bit of overlap. So there might still be a difference. What we need to do now is use what's called a t-test for, well, a hypothesis test called a t-test in order to determine whether or not there is a difference between the two. And remember that we've talked about this in the presentations that I've given to you. This t-test that's done in Excel is a little bit different than a true formal t-test using a t-value table and all of that we went through. It's actually much easier to do this in Excel. What Excel is doing is when you conduct a t-test in Excel, it gives you really the probability value associated with the t-value that you've gotten. So you're really getting a p-value. Anyway, too complicated. But basically you need to remember that when we're in Excel, if you do a t-test, in biology, if the value of the t-test is less than 0.05, 0.05, if it's less than that value, all right, so a small value, then there is a statistically significant difference between the two data sets. Anything bigger than 0.05, so say 0.1 or 0.5, that suggests that there's a lot of shared data between the two data sets, and it doesn't really meet that threshold that we've set for ourselves in biology of 0.05 probability value. Or anyway, don't get too confused about it. Basically, if we end up, when we've done our t-tests, with a value that's less than this 0.05, then you can confidently state that there's a significant difference between your two data sets. Okay, so let's try this out. Doing a t-test in Excel is easy, but it's a little bit more complicated than your standard deviation, mean, mode, median calculations that we've done before. So let's erase this and we'll put in t-test. Let's highlight that and make it bold, just like before. All right, now what we want to do is a comparative test. So what it's going to do is compare this set of 15 data points to this set of 15 data points. So here we go. All right, now we go back up again to our formula builder. We click on the side here on this little arrow, not on the sigma, but on the little arrow on the side. More functions. Up comes our formula builder. Great. Now, again, most recently used t-test is there. You can also just search for t-test. Okay, then click on it, double click on it, and then up comes this dark gray box. There's quite a bit of material to put in here. It's not that hard to do, but watch. First thing you want to do, array 1, that's asking you for the first data set. So you've got your cursor there, and what you need to do is go over to your raw data. Don't include your mean, your mode, your median. Don't include any of the other stats that you've done. Just take the raw data. Again, it's C18 to C32, and you highlight it. Then you come back here to array 2. Put your cursor in there, click inside the box, and highlight D18 to D32. This is the Basiloidus data set. Again, the raw data. This is a little bit confusing. When you're comparing two separate data sets in biology, you're going to want to do a two-tail type 2 test. Okay? If you're comparing one set of organisms or samples and you're looking at it before and after treatment, I think technically speaking it would be a type 1 t-test, but almost all the ones that you're going to be doing for me in biology, tails to type 2. Okay? Then what you do is hit enter. And what we get here is a value. Now keep in mind, right? What we're looking for is this. Do we have a situation where we are less than 0.05? Or are we greater than 0.05? In this case, 0.13, all right, is greater than 0.05. Now, therefore, we accept the null hypothesis and we can conclude there is no significant difference between the data sets. Okay, so we looked at it over here. Let's get rid of the formula builder for a little while. We looked at it over here. Graphically, we could see a lot of overlap in the standard deviation error bars. Now we've backed up that sort of graphical analysis of the situation with an actual t-test. The t-value is bigger than 0.05. All right, and that is outside of our level of confidence, and what we need to do is therefore accept the null hypothesis. There is no sig diff between A. Cytherea and A. basiloides in terms of proboscis length. All right, now let's do another one. Again, we've got the second scenario. This one is for mean body mass for the two butterfly species, and you can see not as much overlap between the error bars. There might be a difference between these two. Let's take a look. So again, we need to do the following. We're going to calculate a t-test, not for our original proboscis length data, but for our body mass data. We click on this t-test. Let's just copy that, boom, put it in here. And now what we need to do is run, again, our t-test. Looking again for this value threshold of 0.05. Let's see what we have. Okay, so yeah, formula builder. Let's do this. Back up here, more functions. Let's. What are you doing, computer? There we go. Okay, bump this over. Again, t-test should come up as the most recently used one. Just simply click on it. You've got these 4 boxes to fill out here. Again, tails 2. The type of t-test will be 2. Our first array is the body mass data for A. Cytherea, the 15 data points that we have. Highlight it. Don't include anything else. No means, no average. Don't put that in there. Then click in the array 2 box. Highlight the A. basiloides data set. And then we've got it all, right? The 2 arrays, tails 2, type 2, enter. Ah, interesting. Again, now, what we have here, what are our 2 scenarios? We've got, are we above or below the 0.05 threshold here? In this case, what we have is a number that's far smaller than 0.05. So therefore, we reject the null hypothesis. All right? And what does that mean? There is a significant difference between the data sets. All right, so in this case, what we can see is that once we've done our t-test, we have this value, all right? It is below 0.05, it's 0.0033, and in this case, this is below our threshold, and what this is showing us is that there is a significant difference between these two butterfly species, this one and this one, for body mass. Which one is more massive? It turns out, let's look at our mean. A. Cytherea, this guy over here with the broader orange patch in its wings, is more massive, heavier in terms of its grams per individual. All right, it doesn't. What it's showing us is that there is no difference really between these two species in proboscis length, but this one right here is statistically, we can state with confidence, statistically speaking, more massive, all right, on average. So good, great, fantastic. I hope that is enough for you. Again, significant difference here, no significant difference here. Hopefully you'll be able to replicate this type of analysis when you do other experiments, not just these little practice demos that I've set up for you. All right, very good.